Hello everyone. Today's video is on confidence intervals and how to estimate them. In order to do so, we need to understand the concept of confidence interval. Let us take an example where we have an orchard, okay, and then in that orchard there are more than apple orchard where there are more than 10,000 apples. Now we want to take a sample and make a guess as to what the average weight of the apples would be in the orchard. Now there are two ways to do it. One is to pluck all the 10,000 apples, weigh them and calculate the average. Or we can take a sample and bake it, and from this particular sample we can draw our conclusions as to what would be the likely mean of this orchard. So what we can do is we simply take a sample, and this sample is random, and on this basis we can just decide as to what the population mean is going to look like. Now, every sample that we draw, let's say 10, 10 apples, 20 apples, 25 apples, depending on the size of the sample, let's assume that we have drawn a sample of 10 apples and each of them would weigh, close together but slightly different depending on the natural variation which is present in the orchard. So let us assume we draw the first sample, and depending on the type or the size of the mango, or sorry, the size of the apples which have been plucked, let's say our sample mean for that particular sample is 149. We draw another sample of, let's say, 25 apples and we find that our sample mean is 130 grams. We draw another sample and we find that the sample weight, average weight or the mean, whichever you want to call it, is 153 grams. Now the question is, who is right, who is wrong? What we are trying to do by drawing these samples is we are trying to predict the population average, and we know that we can only predict the population average with 100% accuracy is when we take down all the apples and weigh them. So by sampling we can only predict a range. So if you see from here, this slide makes it very clear that different persons or different individuals or the same individual drawing different samples would give different results. So we cannot say that it is 149 gram, we cannot say it is going to be 130 grams, and we cannot say it's going to be 153 grams. When we are talking of confidence intervals, when we are talking of predicting the mean of the population, we always talk in terms of confidence intervals. We never say that the mean is 149 grams. We never say that the mean is 130 grams. We never say that the mean is going to be 153 grams. What we say is we give a range, and that range is called as confidence interval. So we can give a range saying that our population mean could lie between 145 grams to 155 grams. So now if you were to take a sample, that sample would likely to fall in that particular, let's say you take a sample of 10, you take a sample of 20 and you weigh, it's most likely that the mean of that sample is going to lie in the range that you have given. So this is the concept of confidence intervals. So what we are saying here is that when we make these confidence intervals, we say that the population mean lies, we don't know the population mean, but we say that the population mean lies between the upper and the lower ranges that we have, or the upper confidence level and the lower confidence level that we have made or suggested. Now, whenever we are doing such an exercise, our question is, what is the mean weight of all the apples? So the question is about, we are taking a sample and we are making an inference about the entire population. So that is why we have to be very confident. When we have to be very confident, we cannot simply say that okay, it could be 130, it can be 153. So we always talk in terms of confidence level. Now, when we draw a sample and when we generalize the findings from that particular sample to the population, there are certain things which determine how precise or accurate we are in terms of predicting the population mean. So let's assume that the sample mean of a sample that we have taken of 10 apples, the sample mean is 149 grams. Now, we can simply say that the population mean of the orchards in the of the apples in the orchard are likely to lie between 147 grams and 150 grams, 151 grams. This makes us more confident. That is why we use the word confidence intervals, because we are more confident now, because if we give a point value, we can never be very, or we can give, if we give a point estimate, let's say 147 or 151 or 147.5, we can never be confident, because we can only be 100% confident when we take we do a census, when we take down all the apples, we pluck all the apples and we weigh them. That's the only situation where we can be 100% sure. So it is always advisable to choose a confidence interval. Now, how this confidence interval is constructed, we'll discuss very briefly, and then we'll go on to see how it is done in reality. Now, understand a couple of things. The variation in the population. Now, if you look at this, there are two populations. Let's take the case. This is one orchard, this is another orchard. So if you look at this particular orchard, the variation is very less. That means most of the apples are 149, 150, 151 grams, 148 grams. But if you look at this particular orchard, you see a lot of variation. Apples are of different sizes. You can find an apple which is 142 gram, you can find an apple which is 172 gram, you can find an apple which is 100. So there's a lot of variation here. So when you have a lot of variation, when you have a lot of variation, you will have wider confidence interval. Here you can be pretty sure if you take a sample and you find, and obviously the sample is going to come from this. Let's assume that you are going to take a sample from the first orchard. So if you take a sample from here, most of the apples would be 148, 150, 151. Whereas if you take a sample from here, and if the sample is sufficiently large, 10, 15 in size, you will find that you will have apples which weigh, which are where there's a lot of variation. So you can find an apple which could be 172, and you can find an apple which is 151, you can find an apple which is 132. So when you have lot of variation, your confidence interval is likely to be bigger, because you can never be sure. Your confidence interval cannot be smaller. It is very natural. Here the confidence interval is going to be smaller. Here the confidence interval is going to be bigger. So what do we conclude? If the population has lot of variation, then the confidence interval, all things being equal, confidence intervals would be bigger. In this instance, the confidence intervals would be smaller if the population has less variation. So populations with low variation, similar samples will show, similar samples if you were to draw, they will show less variation. If the population is large, and it has, when I say large, it means it has a lot of variation, and when we have a lot of variation, then obviously the samples that we will draw, they will have a lot of variation. Okay, so now ultimately what dictates the size of the confidence interval, or how big or small the confidence interval are going to be? One is the variation, the other is the sample size. Now, if I ask you to take only 3 apples and make a prediction about the entire orchard, and I will give this task to somebody else, and I ask that person to take a sample of say 20 apples and predict. So the person who has 20 apples has more information, and he will be able to capture the natural variation present in the population. Similarly, the person with 3 apples may not be able to, incorporate within his sample the natural variation, because he has very little information. He just has a sample of 3. So lesser the sample size means less information, means your wider confidence interval. Why? Because we don't know. One apple could be 180 grams, one apple could be 132 grams, and one apple could be 151 grams. So to predict the population mean, we'll be less sure. We don't have information, so we'll think that the range is pretty wide. I have just 3 apples and the range seems to be pretty wide. But when we have a bigger sample, we have more information, and this would result in a smaller confidence interval, because ultimately the sample is coming from the population. So if the population has larger variation, you will be less confident, and when you will be less confident, you will have bigger confidence interval. So that means you would want a better range, you would want a wider range to be sure that you are predicting accurately. Okay, so sample size is very, very important. So they are two important things. There are two important things. One is the sample size, the other is the variation. Now the third thing, there is another concept. The another concept has to do with something called as confidence level. Okay, so we will talk of this confidence level in a few minutes, but before we go ahead, why is this confidence level important? One is when you are predicting the mean of the population, so there you are talking of confidence intervals. The second thing is the concept of confidence intervals are an integral part of hypothesis testing. Okay, so when we talk of t-test and all these, the it becomes, it becomes an integral part of significance testing or hypothesis testing. In this video, we are only going to be discussing about the confidence interval. We have already discussed what t-tests are, and so the process remains the same. It is only about the inference when we come to hypothesis testing. Now let's come to something called as how confident we are, how certain we are in our prediction. That is how confident we want to say. Let's say somebody says that, okay, fine, I have made a prediction that the sample mean is going to be 149 with plus minus 3. But that person, if you ask him how confident you are in your prediction, he says, oh, I am just 50% confidence. So that doesn't make any sense. So the concept of confidence level is there. You can only be confident 100% when you take an entire census. So you can never be confident 100%, but you can be confident to a tune of, let's say, 95%, 99%. So this is the concept of the confidence level. Generally accepted confidence levels are, when I say accepted, I mean accepted as a theoretical value. It could be anything. You are free to choose the confidence level. You can choose 99.999, you can choose 80, you can choose 50, you can choose 90, but generally the trend, I should say, not generally accepted, the trend is 90%, which is not so common. 95% confidence level is very, very common, and it is there in most of the softwares by default. And when you want to be highly confident, you want a very strict measure, you use 99%. But generally speaking, people tend to use 95% as the confidence level. So confidence levels are also important. So if you want to be more confident, you would have a bigger interval, because you want to make sure that the true value lies there. So bigger the, if you want your confidence level to be, you want to be more confident, there is a trade-off. So your confidence interval is going to increase. So generally we can choose 99, 90, 80, but the most common is 95. Okay, so this is called as the confidence level, and this has relationship with significance. So 1 minus your confidence level is your significance level. We can choose any confidence level that we want, but we have to pay a penalty. Higher the confidence level, bigger will be the confidence interval, because we want to make sure that we are not leaving anybody out. We are not leaving any value out which might be true value. So we first decide on our confidence level. When we want to compute the confidence intervals, we decide on our confidence level. We want to be 95% confident, we want to be 90%. This is a theoretical value. Okay, so the confidence level computations actually depend on the confidence level that you have chosen. So the confidence interval calculations are dependent on confidence level. If you choose 95%, you have to substitute the value of 95%. If you choose a value of 99, you have to substitute the value of 99 in the formula. We have discussed this in our earlier videos. So the size of the interval is determined by the size of the confidence level that we choose. So we have been stating this. Now let's move ahead. So if we choose a lower confidence level, if we choose a lower C, that would mean that either C could be your confidence level or your confidence interval, whichever way you would want to look at it. But ultimately, there is a trade-off between confidence interval versus confidence level. Higher the confidence level, bigger the confidence interval. Smaller the confidence interval, lower would be your confidence level. So what do we mean if we say that we have a 95% confidence level? What do we mean by this? What are we trying to say when we say it is confidence level is 95%? Then we are saying I am 95% sure that the interval contains the true population mean. That means if we were to draw 100 samples, 95 of those samples would actually contain the true population mean. Some of the samples would not contain the true population mean. What do we mean by this? What do we mean by this? It means that there is always a chance that if we take 10 samples, if we take, let's assume for a minute, if we draw 10 samples, it could mean that we have drawn all apples which are 182 grams. There is always the probability that we may end up drawing a sample which contains all 10 apples which are 132 grams, or all apples which are, which weigh on the higher side or the extreme side, or there is always a probability that our sample could contain all those apples which are on the left extreme, which are of a very small size or which weigh very less. So that's the probability is there, but that probability is very, very, very less. So that is why we exclude those values. If you understand the normal distribution, we generally tend to exclude those values which are in both the tails, 2.5% on the right tail and 2.5% on the left tail, because those are extreme values. And we know that when we say 3 standard deviation away, it means 99.7% of the values are contained, within the normal distribution curve. When we say 3 sigma, 3 standard deviations away, 2 standard deviations away, 95%, and when we say 1 standard deviation away, 68.2%. So this is the concept is derived from your standard normal distribution. Also, we are saying that there is a 95% chance that the interval I have provided completely misses the true population. That's what I was trying to say. So there is always a chance, and that chance is 5%. Okay, that chance is basically your 5%. Or what we are trying to say alternately, when we are doing a significance testing, we say that we are 95% confident that the results have not occurred by chance. And what do we mean by chance? Chance means that we are getting one sample which has all apples which weigh 182 grams, which are obviously on the higher side. What we are trying to say is that we are 95% confident because the probability of getting a sample which is on the extreme, on either ends of the distribution curve, is very, very low. So we are saying that we are 95% confident that the results have not occurred by chance. Chance would mean that it was such a lucky day that we actually, or an unlucky day, we actually picked up a sample which was on the extremes, and we are predicting the population mean based on that, but they are very far from the population mean, we know that. So that's the risk as a researcher that we need to take. So what is your margin of error which is added to your mean? When we draw a sample, we compute the mean, and there is a margin of error which actually tells us what we are going to add or subtract to the mean, sample mean, which is also called as the point estimate, to get the final confidence interval. The lower confidence interval, we need to subtract it. For upper confidence level, or we need to add the margin of error. Okay, so for example, 120 plus minus 6, so margin of error is 6. We add this, so our confidence interval becomes 120 minus 6, it is 114 to 126, with 120 being the sample mean or the point estimate. It is also called as point estimate. So we will just move on here: lower confidence limit, upper confidence limit, and we have the point estimate. Now let's start with this. You need to be very, very, sure about the terminology that you are using. So when we are talking of the population, we always talk of the population mean, which is represented by mu. And for populations, we calculate something, whether it is mean, standard deviation, correlation, coefficient of variation, we call them as population parameter. The same things, if the same things that we are computing, mean, median, mode, whatever we are computing for a sample, we call that as a sample statistics. Okay, so always remember this. Now I take up an example. My example is pretty simple. I say if the population mean is 98.6 degrees and a sample of n is equal to 5, which is 5. Now we have taken 5 temperature readings. That means we have taken 5 temperature readings from 5 different people, and this temperature, obviously 5 different readings from 5 different people, we can calculate the mean. So this means comes out to 99.2. So what is our error? So our error is, this is the population mean. We say that the normal body temperature is 98.6. So we subtract 99.2 from 98.6 or vice versa, and we quote the absolute values. So what is the error? Error is 0.6 degrees. That means we are, we have made a our error is 0.6 degrees. So if we were to make a confidence interval, we can derive a confidence interval from here. Okay, so let's take up something in the same lines. So we have a population for which we are trying to predict the mean, and it is unknown to us. We draw a sample, and thus we calculate the sample mean. Let's say the sample mean is 50. So you make a confidence interval based on your confidence level. So you say that I am 95% confident that my predicted mean, you are predicting, is between 40 and 50. So these are your lower confidence limit and upper confidence limit. So you can say UCL and LCL. So this is UCL, upper confidence limit, and this is LCL, lower confidence limit. Okay. So if you want to express this, we have seen this point estimate is your mean plus minus critical value multiplied by standard error. So standard error and critical value actually come out to something which we call as an M, which we were just discussing. So I can just take the pen, and this entire thing is basically what we call as an margin of error if you want to call it. And this is your mean, sample mean, plus minus your margin of error, which we have just seen. Now when we are talking of this critical value, this depends on the kind of distribution that you are using, whether it's a t distribution or a z distribution, and these have different values. If you are taking 90%, t will have a different value. If you are taking 90% for z, it will have a different value. Similarly, if you are taking a if you are taking a 99% or 95% or 90%, so the t values will be different as compared to the z values, but they are a multiplier. So higher these values are, I mean, if both t and z are high, it will depend when you are going to use t and when you are going to use z. Okay, so you are going to use z when the population is very large and the the standard population standard deviation is known, which is rarely the case. Most of the time we are in a situation where the population standard deviation is unknown to us, so we take the t distribution. But when we are talking of the softwares, the software hardly bothers. You only have to specify, in some softwares you have to specify that the population standard deviation is unknown, which is generally the case. So this is basically the formula, and we can move ahead from here. So let's come to this. The confidence intervals can be calculated not only for the predicting the population mean, but also for the population proportion, also for standard deviation, also for the variance. So population mean can be, so the confidence intervals can be made for anything that we are trying to predict. If we are predicting the standard deviation, we will have, from a sample, we will have the confidence intervals. If we are trying to predict the variation, we will also have the, or variance, we will also have the confidence interval. So, but for our purposes, we are only interested in the population mean. So this is something which is going to be of our interest. So I'll just highlight this. We are going to be only interested in the predicting the population mean. And when we are trying to predict the population mean, we are faced with two situations, and one is where the population standard deviation is unknown to us. This is going to be the case most of the time. Okay, so always remember, most of the time we don't know the population standard deviation, so we are not aware of what the population standard deviation is. So this is the formula that we are always going to use. So this is normally the case. Always use t distribution if the sample size is less than 30 and we don't know the population standard deviation. And we use a Z distribution if the sample size is greater than 30. We also use this Z distribution if the sample size is less than 30, but we know the population standard deviation. Okay. Now, from here on, we are going to understand how we can use Excel templates to uh, predict the population mean based on a sample. Okay, so we have templates which can also be used for predicting sample sizes or proportions, but we are only interested in this confidence interval template for beans. So let us see how we can do this quickly. Okay, let's assume we have a problem. An auditor takes a sample size of 49. So we have a sample size of 49, which is greater than 30. To estimate the mean value of daily, so we have to estimate the mean value from a sample of poor incoming quality. The sample value, we take the sample and the mean value for that particular sample is 340 rupees. The sample is standard, note the word, the sample standard deviation is given, the population standard deviation is not given, okay. So we will choose the option of sigma unknown. The sample standard deviation is 230 rupees and we have to form a 90% confidence interval for the true mean scrap value. So we have to remember these three, 49, 340 and 230. What we'll do is, if we want to solve this, we will straight away go to Excel templates. So we'll open up Excel templates and we'll open up a template called as confidence interval template. When we open up this confidence interval template, we find that there are two sheets. One is to do with the sample data when you are given the sample data. So that is the raw data. The raw data is not given to us. The problem has already, in the problem, the sample statistics are given to us. That is, the mean is given, the sample size is given, and the sample standard deviation is given to us. So we will not use the sample data one, we will use the sample statistics. Okay. So when we go for the sample statistics, we are trying to predict the confidence interval for the mean. So sigma is not known to us, that is the sample standard deviation. We only know the sample standard deviation, we don't know the population standard deviation. So we'll go to the bottom one. So our question, we know the sample size is given to us, the sample mean is given to us, the sample standard deviation is. We can look at the problem once again. So 49 is the sample size, 340 and 230. So we need these values. The sample size is 49. Sample size is 49. And this is, I'll just have a look once again. And so this is 340 and 230. That is, your standard deviation is 230. So we'll put the standard deviation as 230 and the sample size is, sorry, your sample mean is 340. So as soon as we hit this, enter, we get the confidence intervals. We get the confidence intervals for different confidence level. Okay, for 99%, for 95%, for 90%, and this green is 80. You can put in any value that you want. For 50%, you can get this. So we are interested in the 91. So 91, we look at the corresponding and it gives us, so 340 is your point estimate and 55 plus 1, 55.10 is your margin of error. So when you add and subtract to this point estimate, you get 284 and 395. This is your lower confidence level LCL and this is your upper confidence limit. Lower confidence limit, upper confidence limit, this is called as UCL. And so you get these two values and that's it. If somebody were to ask you for 99, you look at the top one. If somebody were to ask you for 95, you look at the second one. So we have another problem now. We can have a look at another problem. The problem is, in Mumbai, military personnel live and they have to be given, subsidized housing. So a randomly selected sample of enlisted men and women living off the base gives us the following information: that the sample size that was there is 100 and the mean monthly expenses is 8200 and the sample standard deviation is 1200. So based on this, we have to predict the population mean. So sample size is 100, 8200 and 1200 and we have to form a 95% confidence level. So we have to remember these values. We can once again go to, because the sample statistics are given to us, so we have to use the sample stats, not the sample data. And in sample stats, the sample standard deviation is given, so we will not use the sigma known, that is population standard deviation. So we'll use the bottom one and we'll input the values. So the sample size is 100. This is sample mean is 8200 and the sample standard deviation is 1200. Okay. So we can compute the confidence level for 95% as 82,000 plus minus 238, so which becomes 7691 and 8438.11. So what are we trying to say? That if we were to sample all the people, all the army men who were living, men and women, who were living in Mumbai, and if we were to sample, not sample, if we were to calculate, if we were to take a census, we will find that the true value will lie between 7961 and 8438.11, 95% of the times. Okay, in other words, 95, if we were to draw 95 similar samples of size 100, we will find that the mean is likely to lie in this particular range if we want 95%. If we want 99, and you can see I was telling you that if we increase the confidence, if you want to be more confident, our margin of error increases. So you can see the margin of error here becomes 315. If you want to be less confident, it goes on decreasing. So you can see the highest is when you want to be the most confident. And when you want to be the most confident, what does it mean? It means that you don't want to leave out any possible chance. So when you don't want to leave out any possible chance, that means you are increasing your area under the curve. And when you increase the area under the curve, you are likely to include, your confidence interval becomes wider. So the width becomes wider. So this is an example which we have seen. So let's look at this. Our random sample is of n is 25, x is 50, and sample standard deviation is 8. We have to compute a 95% confidence. So n is 25, x is 50, and this is 8. So we'll go to our 25, 50, and standard deviation is 8. So as soon as we put these values, we get the confidence interval. And the best part about the template is that it calculates or computes the confidence intervals for the 3 popular confidence level, and it gives you an option which is in green to use any option. For example, I want to compute for 97%. So I can just input 97 and it will give me a confidence interval for 97%. So if I have to compute for 95, I have to code this. If I have to compute for 99, I have to code this. If I have to compute for 90%, I have to code this. Or if I have to compute for 97 or any other value which is given to me, which is not given by the software, I can just change the value here and I can give you the, or I can give the confidence interval. So I hope you found the video interesting. Thank you.